Hello students, welcome to business mathematics class. So, in this class we are going to again continue with the chapter determinants, and here we are going to discuss about minors and cofactors, right. So, let us start with minors. Now, let us take a look at the slide. Now, what do you mean by a minor? Now, remember, in any determinant, however the number of elements be, the number of elements must be equal to the number of minors. So, what is a minor? The minor of an element is basically the determinant that we get by deleting the row or the column in which the element exists, right. Now, if there are 4 elements, then there are 4 minors. If there are 9 elements, there are 9 minors, right. So, minor is basically the determinant. We have to delete the row or the column of the element in which it exists, right. Now, minors are represented by m, right. So, if we have to find out the minor of, let us say, A11, so we have to use M11. So, M11 will signify that we are finding out the minor of the element that lies in the position row 1 column 1, right. Now, every element in a determinant has a minor. In a second order determinant there are 4 minors, because there are 4 elements, 4 minors, and in a third order determinant there are 9 elements, 9 minors. Now, a minor, like I already said, minor of A11 is written as capital M11 in the subscripts. Okay. Now, let us go to the next slide. Now, as you can see in the slide, I have shown you a order 2 determinant. So, the elements are A11, 11 signifies row 1 column 1, A12 signifies row 1 column 2, A21 means row 2 column 1, A22 means row 2 column 2, right. Now, how do we find out the minors of these elements? The minor of A11 will be written as M11, and how do we find out? Now, we are going to delete the row and the column in which A11 exists. So, as you can see in the slide, A11 lies in row 1 and column 1. So, we delete that row and that column, and the resultant element is the minor. So, the minor of A11 is A22. Similarly, minor of A12 is we are deleting row 1 and column 2, and the resultant element, that is A21, is the minor of A12, right. So, this is how we can find out the minor of a order 2 determinant. All right. Now, how to find out the minors of an order 3 determinant? Let us go to the next slide. Now, order 3 determinant, it is the second order determinant of the element in which it exists. Now, here we have to find out convert this third order to second order determinant of the element that we are taking into consideration. Now, in the right hand side of the screen you can see there is a third order determinant picture. So, here the elements are numbered in the positions. So, A11, A12. So, as we already know, A12 means row 1 column 2, A32 means row 3 column 2, right. Now, let us see how to find out the minors of each element, right. Let us say A11. So, A11 lies in the first row and first column. So, we are deleting the first row and the first column, and the resultant 4 elements will contribute to its determinant, to its minor. So, the resultant elements are A22, A23, A32, A33. So, in the next slide you can see, so the minor of A11 is A22, A23, A32 and A33. Now, let us go back to the previous slide. Let us say the minor of A12. A12, it lies in the first row, second column. So, we will delete the first row and second column, and the remaining elements will be the minors. So, the minor of A12 will be A21, A23, A31 and A33. Now, like this we have to delete the row and the column in which the element exists, and the resultant will be the second order determinant of that element. After that, we know how to cross multiply the diagonal elements, and then the resultant will be the minor of the order 3 determinant elements. All right. Now, as you can see M13 in the screen, M13, that means the minor of A13, the minor of 21, the minor of A22, the minor of A23, the minor of 31, A31, the minor of A32, and finally, the minor of A33. Now, remember that after we find out the second order determinant, the that is not the minor. We have to cross multiply and find the residual value, and that is the minor of the said element. Now, let us understand it better with the help of some examples, right. Now, for example, if I take this order 2 determinant, now if I have to find out the minors of this determinant. So, there are 4 elements, so there has to be 4 minors, right. Now, the minor of A11 means here this is A11, right. So, what do? I delete the row and the column in which the element exists. So, what is the resultant? That is the minor. So, M11 is 3, right. Similarly, M12 means the element is -2. So, I delete the row in which -2 exists, and then I delete the column, and the resultant element is the minor. So, 4, right. Next, M21, that means 4. So, 4. Now, I delete the row in which 4 exists and the column. So, the resultant is -2. I write -2. Similarly, last one 3. So, 3 row and column. The resultant is 1. So, there are 4 elements, there are 4 minors, right. Similarly, let us do another problem. Let us say this is another determinant, I have to find out the minors. So, M11, so I have to delete the row and the column in which A11 exists, and the element is the minor resulting element. Similarly, for 4, I delete this and the resultant is -3, right. Similarly, for M21, that means 3. So, the resultant is 4, right. Now, finally, A22. So, I delete the row in which 0 exists and the column in which the 0 exists, and the resultant element is the minor. So, this is how we find out the minors of an order 2 determinant. Now, let us find out the minors of order 3 determinant, where there are 9 elements, 3 rows and 3 columns, right. Okay. Like I said before, we have to convert it to first a second order determinant, and then you find out the minors, right. Let us take an example. Let us say okay. So, this is the determinant. Now, there are 9 elements. So, I have to find, there has to be 9 minors as well, right. Now, let us find out the minors. Let us say M11, M11 means the minor of A11. So, this is how it is represented, M11 means the minor of A11. So, this is the element 9. Now, what do? I delete the row and the column in which 9 exist. So, what is remaining? These 4, -1, 6, 0 and -2, right. This is remaining. Now, what is the next step? I cross multiply and find the difference of the diagonal elements, right, the parallel diagonal elements. So, that is -1 into -2, and this is -6 into 0. So, it is 0. So, -1 into -2 means 2. So, the minor of A11 is 2, right. Similarly, let us say M12. M12 means which element? 2, right. So, first I need to find out the second order determinant. So, what do? I delete the row and the column in which 2 exist and form the second order determinant. So, what is remaining? 5, 6, 4 and -2, right. Now, what do? I cross multiply. So, 5 with -2 and then the difference of the other diagonal, opposite side diagonal. So, 6 into 4, So, what do I get? Minus 10 minus 24 minus 34, right. So, this is the minor of A12. Similarly, M13, right. Which element? M13 is 1. So, first I need to find out the second order determinant. So, what do? I delete the row and column in which 1 exists. So, what do I get? 5 minus 1, 4 and 0, right. So, what do I do next? Cross multiply the diagonal elements. So, 5 into 0 obviously 0 minus 1 into 4. So, this is 0 plus 4 minus 4. So, the minor is 4, right. Okay. Now for example, now this is how you find out the minors of different elements. Let us take a random element. Let us say, if in the question it is given, find the minor of, let us say, M22, right. Now, how to find out the minor of M22? Same steps you have to use. So, M22 means the minor of A22. Where is A22? A22 means row 2 column 2, that means row 2 column 2, that means here. So, minus 1. So, you have to find out the minor of A22 means M22. Now, I delete the row and the column in which minus 1 exists, right. So, what is remaining? 9, 1, 4 and minus 2, right. Again now I cross multiply. So, 9 into minus 2 minus 18 minus 1 into 4 minus 4. What is the answer? Minus 22, right. So, this is the minor of A22, right. Similarly, let us say M33, right. M33 means third row, third column, that means where is the element? The last element, isn't it? In an order 3, the last element is A33. So, you have to find out the minor of here minus 2. So, what do? I delete the row and the column in which it exists and the resultant, the second order determinant 9, 2, 5 and minus 1, right. What do? 9 into minus 1, that is minus 9 and minus 2 into 5. So, minus 10, right. So, the minor of A33 is minus 19, right. So, you have to remember that here what we are doing, we are not multiplying the element here. Like usually when we find out the value of the determinant, what do? We expand. Whenever we are expanding the row or the column, we take the position sign, the element and then the second order determinant, but here we do not do that. Whenever we are finding out the minor, we are taking into consideration the element, but we are not taking the element in it. We are only taking the second order determinant that it helps us to get out by deleting the row and the column in which it exists, right. Okay. So, now let us say, for example, let us take another one, let us say M21 or M13. M13 means where? Row 1 and column 3, that means this one. So, I delete the row and the column in which it exists and the resultant, that means resultant are these 4 elements. So, these form the second order determinant of the element. So, 5 minus 1, 4 and 0, right. Again cross multiply the diagonal elements. So, 5 into 0 minus, the answer is 4, right. So, this is how you find out the minors of order 2 determinant, which is easier because it only signifies the element, but in case of order 3, what do? You have to find out the second order determinant and then you have to multiply the diagonals and then the difference is the minor of the element. minor is basically the determinant that is obtained by deleting the row or the column in which the element exists. Now, let us discuss about cofactor. Now, minors and cofactors are more or less same, but the only difference is the sign. That means, cofactor is a signed minor. Like, let us take a look at the slide. So, cofactor is defined as a signed minor. Signed minor means there is a sign plus or minus, right. So, cofactor of an element is denoted by capital A I j, where I is representing the row and j is representing the column, right. Now, how do we know what is the sign that we have to use before the minor? Now, we have to use this simple formula, A equals to minus 1 to the power I plus j. Now, I means row, j means column. For example, if we have to find out the sign of, let us say, A22, A22, that means you have to put it in the formula minus 1 to the power 2 plus 2. So, 4, that means the sign will be plus. We have already discussed about positional signs. So, if you all remember the positional signs, then you can easily do the cofactors of determinants, right. Now, let us take a look at the slide again. So, the cofactor of an element A I j is denoted by capital A I j, which is defined by A equals to minus 1 to the power I plus j into m. M means the minor. So, the sign and minor, that becomes the cofactor, right. So, where m is minor of A I j means the element that we are taking into consideration. Hence, the only difference between minor and cofactor of related entries is only the sign, right. So, it may be noted here that A I j equals to m I j or A I j equals to minus m I j. So, the value will be the same, but the sign of the element may change. It may become plus or minus, right. Now, let us take a look at the next slide. So, we have already discussed the order to determinant minors. So, A11, so the minor of A11 will be A22, the minor of A12 will be A21, the minor of A21 will be A12 and the minor of A22 will be A11. Now, how do we find out the cofactors of the this order, right? Now, the cofactor of A11 will be plus. To the right side of the screen, you can see the diagram in the picture where I have put the position signs of the determinant. So, plus, minus, minus, plus. Why plus? Because the position comes to an even number. So, I have already discussed that if the row number plus column number equals to even, then the position sign is plus. If the row number plus column number equals to odd number, then the position sign is minus. So, you can either remember this or the formula minus 1 to the power I plus j, or you can simply remember the diagram that I have put on the screen, right. So, the cofactor of A11 will become plus A2. Cofactor of A12 will be A21, but with the sign change, that is minus, right. Similarly, the cofactor of A21 will be minus. Cofactor of A22 will be plus A11, right. Now, let us take a look with the help of an example, right. Now, so if this is the second order determinant, now let us find out the minors first, so that you can understand it better, right. So, M11 means what? M1 means minor of A11. So, what is the minor of A11? So, we delete the row, right, we delete the row and the column in which A11 exists, and the remaining is the minor, right. Now, we have to use the signs, because if we have to find out the cofactor of A11, the cofactor of A11, that is represented as capital letter 11. This is the cofactor, right. So, what sign will we use? So, we have to remember the positional signs, right. So, what is the position of A11? Plus. So, it will be plus, right. Now, similarly, M12, that means, sorry, here, or for further proof, let us say we know A11 is I plus j. So, 1 plus 1 into m is how, what? M is 3. So, minus 1 to the power 2, the sign is plus. So, plus 3. So, whether we remember this diagram, or we remember this formula, or we remember that if it is an even number, the position sign sum, then whichever thing we remember, we must know that the minor and the cofactor, the difference between minor and cofactor is just the sign. It may be the same, it may change to minus, right. Now, let us say, so the minor of A11 is plus 3 and the cofactor is plus 3, same. Similarly, let us say M12, that means the minor of A12, A12 means in which the element A12 exists. So, we delete the row and the column, the resultant is 4, right. Now, how do we find out the cofactor? Minus 1 to the power the row number and the column number. So, 1 plus 2 into the minor, minor is what? 4. So, minus 1 to the power 3, that means the sign will be minus. So, it will be minus 4, or if we remember the diagram, we know the sign is minus. Now, remember, if it had been minus 4, so the minor would have been minus 4, but the cofactor sign says minus. So, now it will turn to minus 4, minus into minus 4 is plus 4. So, the minor was minus 4, but the cofactor has changed its sign to plus 4. So, that is why we must remember the positional signs of the elements, right. So, first we need to find out the minors and then the cofactors, right. Now, let us find out the minor and the cofactors of a order 3 determinant, right, order 3. So, this is the order 3 determinant, right. Now, let us say I have to find out the cofactors of, let us say 1, 2 and 2, 2, that means A12 and A22. So, let us start with finding out the minor, right. So, minor of A12 will be what? First, we need to select the element. So, element is 1, 2 means row 1, column 2. So, row 1, column 2, that means 2. So, we have to delete the row and the column in which 2 exists. We get 5, 6 and 4 and minus 2, right. So, what is the value that we get? 5 minus 2 minus 6 into 4. So, we get minus 10 minus 24, we get minus 34. So, this is the minor of 1, 2, right. Now, I have to find out the cofactor. So, cofactor is minus 1 to the power the position number. So, 1 plus 2 into the minor of 1, 2. So, this is the sign will be minus to the power 3 means minus sign. So, minus sign M12 is minus 34. So, the cofactor will become plus 34, right. Now, if we have to find out the, let us say next is the cofactor of A22, right. Now, we have to find out the cofactor of A22. Now, we can directly write A22, then the position sign and then the second order determinant. A22 means second row, second column. So, second row and second column, that means minus 1. So, the resultant 9, 1, 4 minus 2. What is the sign? Minus 1 to the power 4 plus, right, and the value we get is minus 18 minus 4, that is minus plus minus 22. So, the resultant is right. So, here we have directly used the formula, that is minus 1 to the power I plus j and the minor, the second order determinant that we have got using the element into consideration, right. So, this is how we find out the cofactors of order 3 determinants, right. So, let us do a quick recap. So, the minor of a second order determinant is basically the element that we get by deleting the row and the column in which the considered element is there, is present, right. Now, minor, the difference between minor and cofactor is that minor does not take into consideration the signs before the value, but in cofactor the positional signs hold importance. That means, you have to take into consideration the position in which the element exists. Now, if the position, let us say for example, A22, so A22 means 2 plus 2 4, that means the positional sign must be plus, must be positive. So, the sign will change to plus and whatever the value of the minor. So, you have to take into consideration the position when it comes to cofactors, right. Okay. Now, let us say this is a second order determinant. Okay. Now, let us do a quick recap of a second order determinant. So, the minor, let us say M11 is 0. So, A11 will be how much? Minus 1 to the power 1 plus 1, the position sign, into 0. So, this is plus. So, the value is 0, right. So, this is how we find out the values of minors and cofactors, and it is very easy. The only difference is the sign that we take into consideration. In the earlier classes, we have discussed about determinants, what is the meaning of determinant, how to find out the value of determinant up to order 3, what are the properties of determinants that helps us to solve and simplify solutions, right, and how to find out the minors and cofactors of determinants. In this class, we are going to study about the actual application of determinants. Now, one of the best applications of determinants is to find out the values of unknown variables, and Cramer has been a mathematician who introduced this concept of Cramer's rule to use it to solve these linear equations, right. So, let us take a look at the slide. So, what is Cramer's rule? So, Gabriel Cramer introduced this simple method that solves systems of linear equations using determinants. Now, in an equation we have some variables, unknown variables, coefficient of variables and some constants, the known values, right. So, here I have jotted down variables, coefficients of variables, constants, and we must remember, if there are 2 unknown variables, then there must be 2 equations, 3 unknown variables, 3 equations. And the most important thing is, we can only use this method if the determinant is not equal to 0, right. The determinant of the coefficient is not equal to 0, right. So, for example, if I write 2x plus 3y equals to 15, so x and y are the unknown variables, 2x, 2 is the coefficient of the variable x, and 2x plus 3y equals to 15, 15 is the constant or the known value, right. Now, how do we find out the values, right, using determinants? Now, there are certain steps, simple steps, whether there are 2 variables or 3 variables, we can use it. So, the first step is, you have to find out the determinant d. D constitutes the elements of the coefficients, right. For example, if there is 2x plus 3y, so 2 and 3 become row 1 elements, and if there is another element 4x plus 5y, then 4 and 5 become the elements of row 2, right. So, first we need to find out the determinant of the coefficient, right. Next, we have to find out dx. Now, what is dx? Now, in the dx determinant, we substitute the coefficient of x with the known values, right. dy, we substitute the elements of y with the known values, and if there is another unknown variable, let us say z, so similarly we substitute the coefficient of z with the known values, right. And then we follow this formula to find the value of variable x, we do dx by d, then to find the value of variable y, we do dy by d, and if there is another variable, let us say z, so the formula used is dz by d. Now, we will be able to understand it better with the help of an example, right. Okay. Let us say we have 2 equations here, right. So, 2x minus 3y equals to 3 and 4x minus y equals to 11. Now, we have to find the values of x and y. How do we do it? What is the first step? The first step is, we have to find out the value of determinant. Determinant of what? Coefficients. So, the determinant, right, let us say, okay, let us name it as d. So, the determinant is constituting of the coefficient of the variables. So, here the coefficient of x is 2, here the coefficient of y is minus 3. You must consider the sign. Here the coefficient is 4, and here the coefficient is -1, right. Now, we have to find the value of this determinant. So, we get 2 into -1 minus -3 into 4, right. So, what is the value? -2 minus -12. So, this will become 10, -2 plus 12, right. So, that is 10. So, 10. Remember, the determinant of the coefficient must not be equal to 0, then only we can follow Cramer's rule. So, here the determinant is 10, that means it is not equal to 0. So, now we can follow the next step. Now, what is the next step? We have to find out dx, right. Now, how do we find out dx? In dx, what do? We substitute the coefficient of x with the known values, that means 3 and 11, right. And here what do? The y coefficient remaining the same, that means -1, -3, -1, right. Now, we can find out the determinant value. So, here 3 into -1 minus -3 into 11, right. So, this is -3 plus 33. So, what is the answer? 30. So, dx value is 30. Now, dy. In dy, what do? In dy, we substitute the coefficient of y with the known values, right. So, the x remaining the same. So, 2 and 4, the coefficient of x will remain the same, and we will substitute the coefficient of y. So, -3 -1 will be substituted by the known values. So, 3 and 11. Now, next step, we find the determinant. So, 2 into 11 minus 3 into 4. So, that is 22 minus 12, that is the answer is 10, right. Now, we have to find out the values of x and y. So, the next step is, to find out the value of x, we divide dx by d, right. So, what is the value of dx? 30, and the determinant value is 10. So, we get 3. So, x equals to 3. Similarly, to find out the value of y, we divide dy by d, right. So, dy value is 10. So, 10 by 10, the answer is 1, right. So, this is the value of x and this is the value of y, right. So, this is how we can use Cramer's rule in solving linear equations where there are two unknown variables. In order to verify your answers, you can substitute x as 3 and y as 1 in any one of the equations to verify your answers and see whether 3 is coming or not. So, let us say x is 3. So, 2 into 3 minus 3 into 1 equals to 3. So, 6 minus 3 equals to 3. So, hence verified, right. Now, for example, if let us take another question. Sometimes let us say, let us take the next question, that is 2x plus 3y equals to 13 and 6y minus 9x equals to 0, right. Now, here we notice that they are not in right order. That means, here in the first equation x comes first and y comes later, whereas in the next equation y comes first and x comes later. So, you have to first arrange the variables properly. So, how do we do it? Now, we write 2x plus 3y equals to 13 and here minus 9x plus 6y equals to 0. So, this is the proper order of both the equations. Now, we can follow Cramer's rule. We can use Cramer's rule to find out the values of the unknown variables. So, you first find the coefficient determinant. So, coefficient is 2, 3, minus 9 and 6, right. So, here 2 into 6, 12 minus 27. So, the answer is 39, right. So, 39, that means the determinant of the coefficient is not equal to 0. So, that means we can use Cramer's rule. Now, let us find the determinant of x. So, in x what do? We substitute the x coefficient with the known values. So, 13, 0 and the y coefficients remaining the same. So, this is 78, 13 into 6, 78 minus 0, that is 78, right. dy, what do we do in dy? We substitute the values of y with the known values. So, here the x values remaining same, x coefficient remaining same, we have to change the y coefficient. So, 3, 6 will be converted to 13 and 0. So, the answer is 0 minus 117, minus 117. So, this will become plus 117, right. Okay. Now, we can find the values of x and y. So, x equals to dx by d. So, that is 78 by 39, 78 by 39, that is 2. So, the value of x is 2 and the value of y is dy by d. So, dy is 117 divided by d is 39. So, the value is 3. So, this is how we can use Cramer's rule to find out the values of unknown variables when there is an order 2 determinant, right, when there are 2 unknown variables, say x and y. Now, let us try to use this Cramer's rule in order to find out the values of 3 unknown variables. That means, where there are 3 equations, let us say consisting of x, y and z, right. Now, let us do a quick recap of the steps. So, first we need to find out the determinant consisting of the coefficients, then we will have to find out dx, then dy, then dz and then find the values by using the formula dx by d or dy by d or dz by d, right. Now, let us take an example. Now, when there are 3 variables, that means there are 3 linear equations, right. So, here is the question, x plus y plus z equals to 3, 2x plus 3y plus 4, z equals to 9 and x plus 2y minus 4z equals to 1, right. Now, what is the first step? The first step is we have to make the determinant of the coefficients. Now, what are the coefficients here? Coefficient here for x is 1, for y again 1, for z 1, right. Next 2, for y is 3, 4, for z is 4. Here 1, here 2 and here it is minus 4, right, minus 4. Okay. So, this is the determinant of the coefficients from the variables, right. Now, we have to find out the determinant value of this. So, we all know how to find out. Let us say we are finding it by expanding the first row. First row, so 3, 4, 2, minus 4, minus 1, plus 1, again the second order determinant, right. Now, we get minus 12, minus 8, minus 1, this is minus 8, minus 4, right. This is 4 minus 3. So, here we get minus 20, this will become minus and minus 12. So, this will become plus 12, right, and this is plus 1, right. So, the value is minus 7, right. Now, we have to make sure that the determinant value is not equal to 0, then only we can use Cramer's rule. So, here we see that the determinant value is not equal to 0. So, that means we can use Cramer's rule here, right. Now, what is the next step? You have to find out dx. Now, like how we did it in second order determinant, we substitute the values of x coefficient with the known values. The same step has to be followed here also. So, the determinant here is not equal to 0. So, we can use Cramer's rule now. So, first we need to find out dx. So, in dx, like we did it in 2 variables, we have to substitute the x coefficient with the known values. So, the known values here is 3, 9 and minus 1. So, we write it here 3, 9 and minus 1, right, and then the y coefficient and z coefficient remaining the same. So, here it is 1, 3 and 2, 1, 4 and minus 4, right. Now, we find the determinant by expanding it along the row 1. So, So, 3, right, then minus 1, right, and then okay. So, here we get 3 minus 12 minus 8, right, minus 1 here minus 36 minus into minus. So, it becomes plus 4, right, and here 1 18 minus minus 3 means plus 3, right. So, here we get, so this is 3 into minus 20, so minus 60 plus, so this is minus 32 plus 32, and this is 18 plus 3, this is 21, right. So, the answer is again minus 7. So, dx value is also minus 7, right. Now, let us find out the value of dy. Okay. Now, what do we do in dy? We substitute the value of the coefficient of y with the known values. So, let us do that. So, dy, the coefficient of x and z remaining the same. So, 1, 2, 1, only y coefficient. So, 1, 3, 2 will be substituted with 3, 9 and minus 1, right, and here again 1, 4 and minus 4, right. Again we are finding out the determinant by expanding along the row 1. So, 1, 9, 4, minus 1, minus 4, right, again minus 3, 2, 4, 1, minus 4, right. Then next plus 1, 2, 9, 1 and minus 1, right. So, here we get minus 36 minus minus 4. So, plus 4, here we get minus 8 minus 4, and here we get minus 2 minus 9, right. So, here we are getting minus 32, this is minus and minus 12. So, minus becomes plus 36 and this is minus 2 minus 9. So, that is minus 11. Okay. So, again the answer will be minus 7, right. Okay. Now, so now we have got so far two values. So, dx value is minus 7, dy value is minus 7, right. Now, we have to find out dz. Now, again the same step, the same series of steps we have to follow. We have to substitute the coefficient of z with the known values. So, dz, that means the coefficient of dz here. So, the remaining coefficients remaining the same. So, 1, 2 and 1, 1, 3 and 2, 1, 4, 1, 4 we have to substitute with known values. So, known values means 3, 9 and minus 1, right. Again we have to find out the value of the determinant of z dz by expanding it along row 1. So, again first row means 3, 2, 9 minus 1, again 2, 9 and 1 and minus 1, here 3. So, plus 3, deleting the row and the column in which it exists, the remaining second order determinant 2, 3 and 1 and 2, right. So, here again we will get minus 3 minus 18, here again minus 1. So, here we will get minus 2 minus 9, here again we will get 3, 4 minus 3, right. So, the resultant again will be, so this is minus 21, this is minus into minus 11. So, this will become plus 11 and this is 3 into 1. So, 3. So, again the answer will be minus 7. So, again the value of dz will be minus 7. So, now we have got all our determinant values. So, now we just have to use the formula to get the values of the unknown variables. So, x equals to dx by d. So, dx we know is minus 7 and d we have already found it as minus 7. So, the answer is 1. Similarly, y, dy by d minus 7 by minus 7, 1, z dz by d minus 7 by minus 7 equals to 1. So, the values of x, y and z is 1. Okay. So, this is how we can use Cramer's rule in order to find out the values of 3 unknown variables. Okay. Now, let us take another question. Here also you have to be careful about the arrangement of the variables, right. Now, you have to first see how many unknown variables are shown, right. Now, as you can see in the slide, the question is 2y minus 3z equals to 0, x plus 3y equals to minus 4 and 3x plus 4y equals to 3, right. Now, here you can see there are actually 3 unknown variables, because there are 3 equations, right. So, x, y and z, right, but in all the equations all the unknown variables are not shown. So, what do? We take it as 0. So, when we are finding the coefficient, the coefficients will be like this. Let us say, let us first arrange it. Okay. So, it is in order only, right. So, the coefficient of the determinant of the coefficient will be, here there is no x. So, we will take it as 0, right. Then what is the coefficient of y? We will take it as 2. Here what is the coefficient of z? Minus 3. Next equation, what is the coefficient of x? 1. What is the coefficient of y? 3. There is no z, so we will take it as 0, right. Similarly, last equation, what is the coefficient of x? 3, y 4, and there is no z, so we will take it as 0, and the known variables obviously is 0, minus 4 and 3, right. So, this is how, again you have to follow the same steps. You will find out the determinant value and make sure this is not equal to 0, then only you can use the Cramer's rule. So, for dx what do? You substitute the value with 0, minus 4 and 3, the value of unknown variables. Then the other elements remaining the same, right. Similarly, for dy, what do? You substitute the values of y. So, 0, 1, 3. So, with the known values is 0, minus 4 and 3, and the other elements remaining the same. Similarly, for dz, what do? You substitute the coefficient of z with the known values, right. So, what do? You repeat the 0, 1, 3, okay, 2, 3, 4 and finally, with the known values, right. And then you find out the determinant, and then you use to find the values of the unknown variables with the help of the determinants and all the coefficients determinants that you found out, right. So, dx, so x will be dx by d, y will be dy by d and z will be dz by d, right. So, this is how you can use Cramer's rule to find out the values of unknown variables from by solving linear equations, right. Now, let us do a quick recap of the entire chapter that we have discussed so far. So, here you can see in the slide what we have covered so far. We have covered the meaning of determinant. So, determinant is basically a numerical value that is obtained from a square matrix. So, square matrix is a matrix where the number of rows must be equal to the number of columns, right. Then we have discussed how to find the value of the determinant of order 1, order 2 and order 3 as that of your syllabus, right. Now, the next is how we have also discussed how to use 2 different methods to find out the value of determinant of order 3. There are 2 methods, one is the Saris expansion method, another one is the expansion method by any row or column, right. Next, we have covered the different properties of determinants, right, the 6 properties that we have discussed, where we can use these properties to simplify our calculations, right, how to make quick calculations for determinants, right. Next, what we have done, we have discussed how to find out the minors and cofactors. So, minor is nothing but the determinant that is obtained by deleting the row and the column in which the element exists, and cofactor is nothing but a signed minor. That means, in cofactor we take into account the sign of the position of the element, right. Now, lastly we have discussed how to use Cramer's rule, because the best application of determinants is to solve linear equations, right, and that is where we can use Cramer's rule in order to find out the values of unknown variables, whether there are 2 variables or there are 3 unknown variables. Hope you have understood the topics that we have covered so far. Thank you.